Hello fifth graders, it's Mrs. Tremblay, and today we're going to look at converting mixed numbers into improper fractions and improper fractions into mixed numbers. I know we did a lot of this in class with pictures, and I'm going to kind of show you the standard way to do it. So if you ask somebody at home, can you help me with this? This is probably what they would tell you, but we've got a good understanding of what's happening here from what we did in class. All right, so for A through D on this first page, and you should have printed these notes out. If not, you can do them on line paper. I'll have copies for you when you get back to all kinds of different ways, but you should be following along, and your paper should match mine when we're done. I don't mind you trying the problems on your own, just so long as you come back and check your work to make sure that you're right. You want to listen to instruction. All right, so for letter A, there's just one circle here, right? And we know that when we're writing a fraction, I want to know what fraction of this circle is shaded. So I'm going to look at how many pieces are shaded. There are 5 pieces shaded out of 6, 7, 8 total. So we would call 5/8, right? And this is less than 1. There's only one circle and less than the whole circle is shaded, so that's less than 1. But when you look at B, there are 2 whole circles shaded. And this is where we get into some mixed numbers or some improper fractions. Because improper fractions represent numbers that are, or values that are greater than 1. So if I wanted to write a mixed number for this picture, I would say I have one full circle shaded, right? And then I have 1, 2, 3, 4, 5 out of the 8 pieces. So that would be the mixed number for this. I could also write this as an improper fraction. As an improper fraction, the denominator is still how many pieces one whole is broken up into. One whole is not broken up into 16. One whole is broken up into 8, so my denominator stays 8. So now I want to know how many 1/8 are shaded. Well, in here, there's 8, right? And then 9, 10, 11, 12, 13. So for B, I could say 1 5/8 or 13/8 represents this picture. If I said write your answer as a mixed number, that's what you would write. If I said write your answer as an improper fraction, that's what you would write. For letter C, again, I see that there are 2 rectangles here, like 2 full rectangles. If I was going to write this as a mixed number, I know that I have one full rectangle shaded, and I have 1/6 of another. So 1 and 1/6 could represent this picture. I could also write this as an improper fraction. Each one whole is broken up into 6, and there are 1, 2, 3, 4, 5, 6, 7 sixths shaded. So 1 and 1/6 or 7/6 represent the same value for this. And for letter D, I see that there are 3 whole rectangles here. Only 2 of them are entirely shaded, and then 1, 2/3 of another. It's not 2/9 because one whole is not broken up into 9. One whole is broken up into 3, and that's what my denominator should be. So 2 and 2/3. Now if I wanted this as an improper fraction, I would ask myself, okay, how many pieces is one whole rectangle broken up into? 3, that's my denominator. And how many thirds do I have shaded? 1, 2, 3, 4, 5, 6, 7, 8 thirds. So I could say 2 and 2/3 or 8/3. So when you have a picture, all we're really doing is counting, right? What I'd like us to be able to do is to change a mixed number into an improper fraction without having that picture, okay? So the steps to being able to do this: multiply the denominator by the whole number, add that product to the numerator to create your new numerator, and the denominator stays the same. Now in class, we went through a whole lot of this, right? We talked about this last week. And for 3 2/5, if you can kind of picture this, I would have 3 whole shapes shaded, right? And 2/5 of another. And for this 3, the whole would be broken up into, if you're wondering what that noise is, it's my dog drinking some water. My apologies. Maybe if you can't hear it, you can now notice it. Yep, there she is. Right, so for 3 2/5, in class we had said, well, this 3 would mean I'd have 5/5 plus another 5/5 plus another 5/5, right? I'd have 5/5, there's 1, 2, 3, and then we'd have another 2/5 shaded, right? So you can kind of picture 1, 2, 3 whole shaded and 2/5 of another. And we can then go ahead and say, okay, well, it's broken up into fifths. My denominator doesn't change. And 5, 10, 15, 17 fifths, right? So that's what we had said in class. Let me let her out real quick. Sorry, she likes to do this when I record videos early in the morning. Okay, so the step I had told you over here was to multiply the denominator by the whole number. This 5 is the denominator, right? And the whole number is 3. So what I'm telling you can do is, to get your numerator, you can take your denominator 5 times your whole number 3, and then add the product to the numerator, so plus 2. And once you figure that out, that's your numerator, and your denominator stays the same. So we'd end up doing 5 times 3 is 15, plus 2 is 17 fifths, and get the same thing. Why that works is, this whole number 3, like, wouldn't this mean I'd have to do 5 fifths 3 times? So do you see how I had to add 5 3 times and then the extra 2? Yeah, that's what's happening here. So instead of doing repeated addition, 5 plus 5 plus 5, because I know I'm going to have 5 fifths 3 times, we can just say, oh, 5 times 3. And then the extra 2 fifths on the end, add that 2, and our denominator stayed the same throughout. So if this way makes more sense of writing that whole number out separately, I don't mind if you do that. But if you're ready for just the little standard algorithm way to do it, then go for it. All right, so 2 and 4 fifths. This 2 means that I would have 5 fifths twice, right? So I'm going to take my denominator 5, and I'm going to multiply it by my whole number 2. That's like saying 5 fifths twice. Plus, we would have that extra 4 fifths, right? And every single time, my denominator would be 5. So all we have to do now is solve this out. 5 times 2 is 10, 10 plus 4 is 14, and our denominator never changes. So again, this 2 means that I have 5 fifths twice plus the 4 fifths, right? So 5 plus 5 is 10, plus 4 is 14. Keep your denominator. So instead of using repeated addition of 5 plus 5, the only thing we really changed was 5 times 2, because it's the same. All right, try it for letter F. I have 1 and 7/8. So I can take my denominator 8 times my whole number 1 plus 7/8 of the other shape. And remember that your denominator doesn't change. So 8 times 1 is 8, and 8 plus 7 is 15. And there's our denominator, 15/8. And again, if you're like, that just doesn't make sense to me, if I have 1 and 7/8 and the shape's cut up into eighths, this 1 would mean 8/8, right? Plus, I have 7/8 of another. 8 plus 7 is 15. Oops, and my 8 doesn't change. It's the same. Okay, 4 and 1/10. This means I would have 10 tenths 4 times. So instead of writing 10 tenths plus 10 tenths plus 10 tenths plus 10 tenths, I'm just going to do 10 times 4, the denominator times my whole number, plus I have that 1/10 left. All over 10, because your denominator, yes, never changes. So 10 times 4 would be 40, plus 1 is 41 tenths. That's it. All right, for 3 and 5/9, this would mean that I had 9/9 3 times. So I'd have 9/9 plus 9/9 plus 9/9. And 9 plus 9 plus 9 is the same as 9 times 3. So my denominator times my whole number plus the 5 and the 5/9 extra, all over 9, because yes, my denominator never changes. So 9 times 3 is 27. And then when you add 27 plus 5, you get 32. So 32/9. All right, next. 7 and 3/4. This would mean I'd have 4/4 7 times. So I would be adding 4 7 times. So instead of doing that, I'm going to take 4 times 7. Plus, I know I have this extra 3 in the 3/4 all over 4. So 4 times 7 is 28, 29, 30, 31/4 is what you would have. And for letter J, this would mean I'd have 10 tenths 10 times. Now, rather than writing that, instead of adding 10 times, let's do 10 times 10. The denominator times the whole number. And then we'll add in those 9 out of the 10 pieces. My denominator stays 10. So 10 times 10 is 100. 100 plus 9 is 109 tenths. Okay, so that is changing a mixed number to a fraction. On your second sheet, I have changing an improper fraction to a mixed number. And the directions here say, divide the numerator by the denominator to get the whole number. The remainder is your new numerator. The denominator stays the same. So in class, we did this visually. And we had said, okay, 13/4, in order to figure out the whole number, because I know there's a whole number because there's more on top than on the bottom, right? So 4/4 is 1. If I have more than 4/4, that means I have more than 1. So to find your whole number, you can figure out how many 4/4 are in 13/4. So I know I can pull one group of 4/4, right? So there's one whole. And then if I add another 4/4, that would be 8/4. So yeah, I have 2 whole now. All right, now can I do another one? 4, 8, 12/4, yep. So right now I'm at 4, 8, 12/4, right? I have 13/4. So if I already have 12, how many more would I need to make 13? 1/4. So I can see how many 4/4 there are in 13/4. That gives me the whole number. So right here I see 1, 1, and 1, right? That means I have 3 whole shapes shaded and 1/4 of another. So that's what we had talked about in class in great detail, right? Now today I want us to kind of put this together in just a little bit faster of a way, I guess, than writing that out. And again, if you want to write it out, please do so. Do what you need to do. But you could, if you wanted, say, okay, well, 13 divided by 4 is what? Like, okay, I can't multiply 4 by something to get 13 exactly, so I'm going to have some leftovers. But I would just ask myself, 4 times what gets me closest to 13? And it's just like doing 13 divided by 4. That's what I would do if I was doing 13 divided by 4. Wouldn't I ask myself, how many times does 4 go into 13? And to figure that out, I can go 4, 8, 12. So 4 goes into 13 3 times, right? And that gives me 12, and there's 1 left over, and my denominator never changes. So let's apply this to letter K. For 14/5, I can ask myself, 5 times what gets me closest to 14? Well, if I count by 5s, 5, 10. I can see 2 5s gets me 10. If I did 3 5s, that would be too big, right? So 2 would be my whole number because 5 times 2 gets me closest to 14. Or you can look at it like this, 14 divided by 5. 5 times 2 is 10, right? How many are left? Well, 14 minus 10 is 4. So I would have 2 and 4/5. 2 and 4/5. And you could use what we just did to check your work. Multiply your denominator by a whole number and add your numerator. 5 times 2 is 10, and 10 plus 4 is 14, and your denominator never changes. So again, you can ask yourself, 5 times what gets you closest to the numerator? That's going to be your whole number. That's how many 5/5 there are in 14/5. And then, however many are left, to count from there to what your numerator is, that's your numerator. So for letter L, I have 18/7. Okay, so I want to know how many 7/7 there are in 18/7. So I'm going to count by 7 to get there. So 7, 14, 21. Now 21's too big, right? So take it back. 7, 14. So I know that I can get 2 groups of 7/7 out of 18/7. That's my whole number. Now it's at 14, right? How many more to get to 18? Well, 14 plus 4 is 18, and my 7 stays the same. And again, if you wanted to see that kind of written out, this means 18 divided by 7. I know that 7 times 2 gets me closest to 18. 7 times 2 is 14. And then how many are left over? 4. That's my new numerator. All right, 17/4. 4 times what gets me closest to 17? 4, 8, 12, 16. I definitely can't get any more out of there, right? So I know that there are 4 4/4 in 17. 4, 8, 12, 16. And to get from 16 to 17, that's 1 extra out of the 4. My denominator doesn't change. So again, I'm looking at this as 17 divided by 4. 4 times what gets me closest to 17? Well, 4 times 4 does. That's 16. there's one left over. That left over one is my new numerator, and your denominator does not change. All right, for letter N, I know that 8 times 2 is 16, and 8 times 3 is 24. So 8 times 2 is as big as I can go, right? So that's my whole number. I know I can fit 2 groups of 8/8 into 21/8. So 8 times 2 is 16. To get from 16 to 21, 16, 17, 18, 19, 20, 21. That's 5, right? So there are 5 left over. And what's my denominator? 8, because it does not change. So again, if you wanted to look at this, it's like saying 21 divided by 8. That's what fractions are. They're little division problems. And 8 times what gets me closest to 21? 8 times 2 does. And 8 times 2 is 16. Now, if you wanted, when you subtract this, I know you're tempted to like borrow, to cross off that 2 and make it a 1. And then 11 minus 6 gives you your 5 that we have, right? But in looking at this, like number talk for a second here, I would just count up. Like I know 16 plus 4 is 20, and then 1 more is 21. So if you don't feel like borrowing, you can just use mental math strategies. That works too. And if you're like, no, Mrs. Tremblay, I'm going to cross out this 2 and make it a 1. And 11 minus 6 is 5. And 1 minus 1 is 0, and we're good. Did you get a different answer? No. I don't care which way you do it. Whatever you like. All right. 44/8. So 8 times what gets me closest to 40? Well, I know that 8 times 5 is 40, right? And 8 times 6 is 48, so that's going to be too big. So I can fit 5 8/8 into 44. 8 times 5 is 40. There's 4 left. That's my numerator, and my denominator doesn't change. So 5 4/8, or at this point, I'm guessing you could say 5 1/2, right? Because 4/8 is the same as a half. I know that because 4 plus 4 is 8. All right, last one, letter P. 82 divided by 10. So 10 times 8 gets me closest to 82, right? So that means I can fit 8 10/10ths into 82. And there are, 10 times 8 is 80, 2 left over out of 10. So 8 2/10. And I don't know if you notice 8 2/10 at this point right here. This 2/10 can be written in a simpler way. We haven't talked a ton about this, but I could change this to 8, and I could divide 2 and 10 both by 2. And 2 divided by 2 is 1, and 10 divided by 2 is 5. So you could say 8 2/10 or 8 1/5. At this point in the year, I'm okay, totally fine with 8 2/10. But if you're here at this point, I don't want to stop you. All right, that's our notes for today. In class, we'll be doing a little scoot around the room with these and some whiteboard practice as well. But you are all set with your notes. Thanks for watching.